So in this video we're going to convert this function here, x divided by 4 minus x squared, into a power series. Now x in our numerator and 4 minus x squared in our denominator. Now this looks like a common power series that we know and that we quite often use when we're trying to convert these functions into power series. And what we know is that there is another function, g of x, which equals 1 over 1 minus x, and that has a power series representation of n equals 0 to infinity of x to the n. And the radius of convergence, which is always important when working with these questions, for this one is the absolute value of x is always less than 1. So if those things are all present with that radius of convergence, this one here, we could transfer that into that following these rules. Okay, so working with our function here. Now we've got x in our numerator. Here there's a 1. Now we could deal with that quite easily. What we could rewrite this as is x times 1 over 4 minus x squared. So that would take care of the x. So we've now got the 1 like this series here. Now we've got 4 minus x squared. Now to turn that into a 1 minus something, now the x here, we're not going to be lucky enough to get an x, but we get something similar, we're getting this into a 1. So if we factor out a 4 in the denominator, so now we can go to x times 1 over, and then factor out a 4, so we've got 4 times 1 minus x squared over 4. So that then is the equivalent of that. And then what we could do is this 4, we could bring it out here with this x. So let's do that. So then we've got x over 4 times 1 over 1 minus x squared over 4. Now this x over 4 we've taken out. We can add that into our calculations later, but for now we want to try and concentrate on this. So 1 over 1 minus x squared over 4. Now it's very similar to this where we've got an x. So then this power series here could be x squared over 4 to the n. So that's what we could do with that. We could just break that down one more step before introducing it into this series here. We could then write that as x over 4 times 1 over 1 minus. And then what we could do is square root of 4 is 2. So we could write this as x over 2 and then squared. So then that would be ideal just to plug into this power series here. So let's go for that as our next step. So then we've got, so bringing this up to here, we've got x over 4. So that's what we've got for this bit. And this bit here is what we're trying to correspond to something similar to this. So let's put that then into a power series. So then that would translate into n equals 0 to infinity. Now we've got minus x over 2 squared. Here we've just got minus x. So this x here and this x here, we then just deal with this x over 2 squared inside the power series. So we then x over 2, that would be squared, and then we raise all that to the power of n. So if I just put a square bracket so as we distinguish that. Okay, so now what we've got this power series set up here. Now this x over 2 squared, we can use this now to look at our radius of convergence. So what we can do is we call this our x over 2 squared and set that less to 1. So that would be our radius of convergence. So now what we do is take the square root on both sides. So then we still have in our absolute value x over 2 is less than 1. And then multiplying both sides by 2, we'll have x is less than 2. So that's then our radius of convergence for our new series. Okay. Now we need to finish this off now. So this here, x over 4 is on the outside, but there's still more we can do to the inside of this summation. So now we'll write x over 4, n equals 0 to infinity. Now, as it's x over 2 squared to the power of n, we can just simply write that as x over 2 to the 2n. And that's still the same value as what we had before. Okay, so now we need to break this down now into our x terms and maybe some variables in our denominator. So let's just have a look at that a little bit further. So here we can just break this down now into two terms. So n equals 0 to infinity. So now I'm going to break this fraction apart. So now I've got x to the 2n. That takes care of the top part. Then at the bottom I've got 2 to the 2n, but it's a half. It's basically a half to the 2n. So I'm going to write that next to it, and then you'll see why that is in a minute. Okay, now this x over 4 is over here, but I want to write that slightly different. So instead of 4, I want to bring this in terms here with the same denominator, so 2. So I can write that as 2 squared. And then what I can do is, because this is basically a half, I can just transfer that into there, and that's going to help me then convert this into our final power series. So let's introduce these in there and see where that takes us. So n equals 0 to infinity. Now x to the 2n and another x here, that's just going to be x to the 2n times x. So that's x to the 2n plus 1. So that will take care of that x term. And now basically we've got 1 over 2 squared. So basically then we could add on another 2 to this indice here. So now we've got 1 over 2 to the 2n plus 2. Then that's everything here inside the summation. So now we can just tidy these things up a little bit. So x to the 2n plus 1, I'm happy with that. That can stay as it is. So now we've got infinity summation n equals 0. X to the 2n plus 1, that will stay like that. So now we'll turn it into a fraction. So now we've got basically half to the 2n plus 2. Now what we could do, if we divided all these by 2, so if I just write this, let's just write this down here. 1 half to the 2n plus 2. What I could rewrite this as is 1 over 4 to the n plus 1. So basically I just divide this by 2. That gives me n plus 1, and then multiply that by 2. So that'll give me a quarter to the n plus 1. So I could rewrite that inside here as dividing by 4 to the n plus 1. Then that then becomes my final power series. Okay, so that's that taken care of. My radius of conversion is this one. So now what I'm going to do is, just to finish off, I'm just going to show what this looks like as a polynomial. So if n equals 0, I've got x to the 1. So I've got x, and then 4 to the 0 plus 1, so that's over 4. So that's the first term in my polynomial. Then my second term, so it's always going to be positive, so straight in with a plus sign. So when n is 1, I've got x to the 3. And then my denominator, x is 1, that's going to be 2, so that's 4 squared. So that's 4 squared. And then we can see now the pattern forming. So now we've got x to the 5 over 4 cubed, and x to the 7 over 4 to the 4, and so on. And we can rewrite that without the powers in our denominator. X to the 4 plus x cubed over 16 plus x to the 5 over 64 plus x to the 7 over 256, and so on. And then that then is our answer. So that's our power series as requested. That's our radius of convergence, and this is our polynomial, which will represent our power series. Okay.